So our next speaker is Dr. Ted Selker. Dr. Selker is a world-renowned creator and tester of new scenarios for working with computing systems. His design practice includes consulting to help dozens of startups and large companies, speaking engagements, and innovation workshops. For instance, Colgate, Google, e-government, Herman Miller, IBM, MasterCard, Magic Leap, Philips, you name it, and many startup companies. So Dr. Selker also served as a consulting professor at Stanford University and worked at the Xerox PARC and Atari Research Labs. So let's welcome Dr. Ted Selker. The floor is yours.
Okay. So when I think of this opportunity to talk to this leadership forum, I think about the topic you brought up of design education in the era of AI. And I start by talking about what design is for me. It's making things that people value, as opposed to art where it's having ideas that give people an emotional reaction, or science that is having ideas that are referred to. Now, education in my life has been one about discovery. And sometimes there's mentoring, sometimes there's curricular-based things. But in the end, education for me ends up being useful if it's valued. Evaluation and credentialing, not as important. And so in this talk, I will be going through examples of things that I've made or other people are making that I think might give us ideas about what could be valued. Now, I've worked in AI and user interface for decades. And in fact, my thesis was on AI in education. But I think of AI as being something about reasoning, representation, and learning. Today, we've thought about it more in terms of machine learning. Anyway, in my background, I started learning about design when I was really building the ThinkPad at IBM, and later at teaching at MIT, Stanford, and Carnegie Mellon. I continued to work as a scientist, inventor, product designer, and futurist. The two logos on here of UltraScan Guide and C3, you'll see more of. They're the projects that I'm working on right now. So design is making things of value. And when I teach industrial design, I talk about the function, aesthetics, and evaluation being some things that have to be put together. They are not separate. And evaluation is something that is often overlooked in design communities, but I think it's central, and we have to move it away from the psychologists, or not. We have to embrace what the psychologists know about experimental design and design. Techniques are the things we make things from. So voice recognition is a technique that people worked on very, very long time, trying to make it better and better. It didn't work until we started including models of language, models of speaker, models of communication. And in that way, we made something called listening. So I'm looking for technologies. Things that have value are technologies, not techniques. Now, AI has been a world of techniques. It has so many buzzwords, so many things people have thought about for so long, from rules that make to do reasoning to in the end, concept formation that's based on unsupervised learning. Now, we're not all going to learn everything about hidden Markov models to support vector machines. And luckily today, there are new tools that let non-professionals use machine learning. I particularly find myself using PyTorch and MATLAB, but there's a lot of tools and they're getting better slowly. but certainly they've gotten to the point where Google bases all of its technology on AI since 2011. So the paradigms that we're seeing come forward as computers are everywhere and in everything go from ambient computers, such as this picture on the in this art gallery where this floor that I designed that could tell where you were would react to you and reflect on you to help you understand how you're communicating with other people, how close and what opportunities there were with other people. And as we move forward in spaces, there's so much of this. Robotic paradigms are things that move. I'm going to give you an example of that in a moment. And then the rest of the talk will be about a journey that I've taken from trying to think about things that I call context aware, that is in the situation that you're in, or what that matters, to considerate computing, where I discovered that in my experiments, and I always love to do experiments on everything I build, if you don't get the social feedback right, nothing is valued by people. To peripheral computing, where basically we can't be overloaded. We do too much already, and the more of these computers are in our lives, it comes to the point where 10% of accidents in cars, some of the largest source of accidents in cars comes from interacting with computers. So here is a robot that I'm building, and this image up on the left-hand side shows the inside of a leg recreated with an AI model. This is using machine learning to interpret ultrasonic transducers, tomographically going around a leg to create a 3D representation of what's inside it. Here you see a varicose vein in my leg represented in 3D. And this is to simplify and improve soft tissue imaging so that people that don't have to be spending 6 years learning how to use ultrasound as a transducer medium. And it could, greatly cheapen the imaging that we have. But a more exciting to me for design is not just making things, but making things that people care about. And so I'm going to start off by saying a few things about context-aware computing. Here's a example of a conception we made where this woman, Andrea, is making a movie, and she's in a subway stop in Cambridge, and we measure her galvanic skin response, how much she's sweating, and it goes up and down with the sun shining or whatever's going on, loud noises. But when we listen to her voice and we use machine learning, we can tell when she's videotaping somebody or something that interests her. And 4 times during an hour, she laughed in certain ways that we were able to identify and automatically edit her video to find when the band was playing, when the person was taking a video of her taking a video of them, and so on. So another example of a context-aware situation where we were really successful is there you are with all these windows open, trying to make some order for some customer, filling out a spreadsheet, all these things going on. And what we did is we made something called Disruption Manager that literally took messages that might be about your job, might be about your social life, coming into your field while you're doing this work, and it's basically using an activity model and a topic model to decide whether to take that message and delay it up to 2 minutes, maybe put it in front of or behind another message. By the way, we got 25% more performance from users when we were turning it on. So this AI model making decisions about what to do, how to organize these messages coming to you, literally made people get more work done. So now I want to move on to considerate computing, where we take things about this context and we think about the social feedback. So Empathy Buddy, is the first example. It actually just got a lasting impact award for the paper that was written about it. But basically, we take a message you're typing. Let's say you're saying, I went skydiving last Saturday outside New York. And what it does is it uses an AI model to make a little face. This one's of a surprise. Sorry about the bad artwork. But when we used text, it didn't do much. When we put these pictures up and showed a reaction, kind of a mirror of the emotional statement you're making by the message you're sending, people changed their emails and wrote more calm emails, more descriptive emails. And so it's a very powerful way of making people think about what they're talking about while they're saying things. A similar vein, we watched and evaluated emails coming in and reacted to them relative to how important was this email relative to who it was in your life and what was in the email and how long it might take to respond to. And just by colorizing the email, this kind of ugly ransom note presentation you might be seeing actually made people react more appropriately to the messages that were coming in that mattered to them. And it's especially surprising because this is a very difficult thing to do. And actually, our AI model was only on the order of 70% correct. So some of these were miscategorized, but by designing the user interface in a fail-soft way, we were actually able to help people, and they were able to use their intuitions and the AI model to improve their responses. So the next topic that I wanted to get to was how to move to a world where we're designing things that are not necessarily going to take all of our attention all the time. For the last 50 years, we've been designing computers to just be as though we're the only person there, and that's kind of why we end up having all of these crashes. So we made a model of driving where we watched for cognitive load. And in this experiment, we tested 13 different biometrics to see if we could tell whether a person was about to make a mistake in driving. And we found that a very inexpensive, simple one to make to test for cognitive overload was frequency of pupil dilation. So that's the variation in pupil dilation. And in less than 3 seconds, we were able to tell. And in fact, what we were able to do in the simulation was reduce the load on the person by stopping the text message or whatever, and actually stop them from making a crash. So this is a very powerful thought that we can actually make people not have to focus on too many things simultaneously. An early provocation I made was this helmet. The helmet, you're sitting in a helmet, and there's a computer mediating the communication with the outside world in. And so as there's a loud noise outside, it turns off your book on tape, and it amplifies the outside noise. If you yell or swear about somebody cutting you off, that swear is that loud noise is turned into a horn that makes it a more appropriate statement to the people outside, as though you were a car. It records where potholes are and a bunch of other things. So the idea is to mediate the relationship between you and the world, and to respond in ways that doesn't take your eyes off the road or your hands off the wheel. More recently, one of my PhD students studied considerate systems in the following way. Here's an example in these two graphs. We had people collaborating to do some hangman game, and and one person here is speaking, starts off 80% of the time this person speaking, and maybe it goes down a little bit. But if we make a little statement to them, turn taking, they reduce their dominance immediately, and it stays down the rest of the meeting. And so that's kind of amazing that provocation, when we recognize with the AI model that they're speaking too much, we'll do that. We also, for the person that isn't speaking, have a little provocation. Any thoughts? And they suddenly go from not participating to going up to 35% of the things that are being said. So this is a very simple example, and I've made several examples where we're testing for dormancy, that is how much you're speaking. We do this thing about extraneous noise. Instead of trying to only get rid of it, we say noisy, and people will reduce their errors in communication to 1/2 of the errors that if a person actually asks them to stop to mute their microphone, we get. So it reduces the stress in a group when the robot makes a statement rather than a person. So we've done this for entrance and exits. We've done it for speaker identification, participant presence, and all of these things are statistically significantly better when we have a robot stating these social issues and coming to the fore while you're trying to focus on a conversation in a video conferencing system such as this. There are these agents trying to recognize and relate whether or not it's appropriate. And so we're putting together context-aware, considerate, and peripheral design. Here's this conference system that I've built. C3.chat is its name. You can play with it. Go online and try C3.chat. And it has this visualization also showing that actually I've been the most recent person speaking, and we've been in the meeting for 22 minutes. So by putting all of these kinds of small, subtle, I hope, reactions, we are in a position to give a person an understanding of what they should be focusing on. And in fact, well, I'd be interested in whether you feel that way. This is all based on a lot of things that I'm thinking about in this book, Peripheral Interaction, that I edited with a couple of colleagues in the last few years. And so really what I'm trying to talk about here is simply thinking about how we're going to be designing things using AI that respect and understand people's needs so that they are able to function with other people as they want to always in social contexts that they're always in, and be respectful of each other and be productive and not overwhelmed. So thank you. There's one more thing I want to mention, which is that over the last over the last several months, I've been working with Jorn Boering in Hong Kong on the future of technology for 2025, thinking about technology-enabled experiences. And so that's just an example of taking some of these ideas back to some of the business people that would benefit from them. So thank you very much for your attention.
Okay, welcome back. Thank you so much, Dr. Ted Selker. And now is the Q&A time. So let's take a look. One question here is, what do you think is the relationship of designer and computer engineer? Is it any difference at the design schools than the industry?
Yeah.
What do you think?
So I have a habit of taking people and requiring them to learn all of the parts. I believe if you don't have any experience as a designer programming, you aren't going to really understand the issues of programming. And if you don't have an experience running real statistical experiments, you're not going to understand how the value of your imagined wonderful thing is going to impact people. So from my point of view, I really go for teaching people all of the aspects and making them have to own as many of the parts of the design process as possible, where I don't think of design process simply as drawing beautiful things in Onshape or something. I believe it's part of understanding the scenario, understanding the people, understanding how well the thing that you made actually does what you think. I've had many experiences where I thought that I had a wonderful, brilliant idea and a design, and I want to hand it off to somebody, and I find actually that the opposite idea is what I end up with after I've done my evaluations. So I'm not sure if I'm saying what you need to hear, but I think that computer engineers we have to become, and the more that we can know all the skills of all the people that we have to work with, you know, and really understand what it is to do the engineering aspects, the better designers we will be.
Okay, thank you very much, Ted. I think we can actually, I think it's a very good question. We can actually frame this question from another angle. For example, I remember Professor Zexian Li, you know, the supervisor of Dajiang, he mentioned probably 2 years ago, and he mentioned in an event, he said scientific innovators and mainly intend to develop the technology and solutions and based on what they can do based on the technology. But what will be a better approach is to develop this technology and solutions based on the scenarios, but not what they actually can do. So there's two folds of this question. One is, do you agree this perspective or not? And the second is, I hope you could explain a bit, because I got the chance to experience your C3 video conferencing tool. That's very exciting. It's very nice. I really enjoyed the bar in the middle, you know, which is showing the overall time, and it's a data visualization, right? So showing the conversation contribution from both parties and how much time you have spent on that and different roles in that. So could you please explain a bit of the developing process and what kind of approach did you take to develop that?
Yeah. So basically, C3 is based on 5 theses, several on collaboration, and some on communication. And so this idea of making people able to see and understand how much contribution they're making to a meeting, we went through many approaches. So we can say iterative design. I actually believe in parallel design. I believe that you should design things in parallel that compete with each other, so you can see which is better. Because and it's very difficult to not come to a point where sometimes when we're designing things, we find ourselves making things and just believing in them because, of course, we designed them. And I really think that evaluation is a big piece of this. No, but in C3, the issues of trying to make people aware of how they're contributing and how other people are contributing to the meeting is all the story. The story is about how I'm being an actor in this collaboration, so that we are going forward in a respectful way. And it's especially important when we are so virtual as we are today.
Yeah. Very good. Thank you very much, Dr. Ted. Another question I think is I would like to ask you is it's people using AI to develop autonomous systems, and autonomous system has the capacity to learn, to improve itself, and with the new functionalities to adapt, to progress. But on the other hand, what we are used to is automation, automatic systems. So which has been, helping us for around a century, to improve the efficiency of how we work and how society, progress. So do you think it's necessary to have such autonomous systems, and how can we deal with autonomous systems compared to automatic systems?
So autonomous to me means that it's acting without supervision on its own. And there are two kinds of agents. I say there are assistive agents that help you, like a teaching agent that's teaching me, and there's autonomous, and there's assistive agents that do them for you instead. I love making mostly agents that teach me, because I want to become enriched, as opposed to do it for me. Even if it makes me drive better, that's exciting too. But that's not what people are thinking about right now for cars, although it would a little change, and maybe we could make people learn to drive better. And I made a thing called Car Coach, where the AI actually trained you to drive better and made you enjoy driving better more, because we're all very good drivers, only we don't do it all the time. So autonomous and self-learning, I really separate a little bit. So the idea of automation, doing things that mechanically are taking our place, that assistant kind of stuff, versus advisory, things that are teaching us, are a distinction I like to make. But also in this other point that you brought up that I think is important is how do we monitor and reflect on something that's trying to learn, so that it is actually learning relative to our goals and needs. And I think that's completely critical. And I think it's all goes back to scenario. How do we design the scenario so that when we're working with the computer or the system or whatever it is, all of the interactions and feedbacks support us and support us doing better? Because unless that's our absolute criteria, we're going to get ourselves disappointed.
Yeah, thank you so much, Ted. I totally agree. I think it's the key is how can we develop the real benefits, something really useful for the scenario, and envision the ideal situations. So we come back to the design education. So here is a question by Jeffrey. Thank you, Jeffrey, who is asking, as educators or scholars, we see the vision of what the design and AI can bring to the society in the future. So how can we make our students to see what we see? How can we bring the vision to the next generation of designers?
Well, I'm always in favor of concrete. I mean, when COVID started happening, I started working with my brothers to make these plastic bags that go over people's heads. And as soon as we did that, we realized there was terrible problems with that. And so So I've been designing this this sensor that's going to measure an alarm when the plastic bag is going to suffocate you. So as a designer, I learn more by designing real things than I do by just discussing it. And I'm always building things. If you look at my fingernails, they're always dirty, even now. And I guess I really believe that we've come full circles in some sense. In the past, people learned just by being near somebody that knew something,
Exactly.
and then we went to classrooms where we, had to do it kind of as a factory, kind of like your automation that you said for the last few decades. But now we have better tools for communicating and better tools for evaluating ourselves as we're learning. And I think that we're ready to go back to actually building things that really matter and we really value as part of our design education, and being in a position where the professors aren't going to be completely overwhelmed by evaluating the designs that are made, but that are different from each other and have different goals, and really have a richer educational experience by working on real problems that are meaningful to the learner.
Yeah, I totally agree, Ted. So following this logic, so which means that, I think going to the workshops, going to the studio, learning by making is the core of design, and I truly believe that as well. So, but in this era of AI, the challenges are different, the working materials are different. The technologies are different. So do you think the technology components is becoming more important in our design education?
Oh, I think they always have been. I think that the tools we work with, people spend a lot of time learning how to sharpen a knife, in the past, right?
Exactly,
now you just
yes.
buy a knife, a blade, and it's sharp. So the AI tools, I've taken students from knowing nothing about AI to building AI models in a couple of days, okay? And so we are really always making tools more and more accessible, because we have to, because otherwise they get used by very, 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 very few people. And so that's the exciting part, is that we actually have much richer tool quiver, that's all of the tools we have in our to work with, than we've ever had. And it's a very, very exciting time as we move away from the world having to be all physical to being very, very virtual, and still allowing us to be productive.
Brilliant. Thank you so much, Ted. That was Dr. Ted Selker, and we're going to come back again in the panel discussion to continue this conversation.